In this lesson, we're going to zoom in and take a look at various tools we can use to interact with HDFS. We're going to review and contrast the features and functionality of Web HDFS, HTTPFS, and Fuse DFS. First up, let's take a look at Web HDFS versus HTTPFS. Both of these systems allow programmatic RESTful access to HDFS, meaning we can interact with HDFS simply by calling URLs either on the name node or on the HTTPFS server. This can be extremely useful for legacy systems to interact with HDFS if, for example, we can't install the Hadoop client on them to run Hadoop FS commands. We can do common file operations like putting and getting files, listing contents of directories or files themselves, making directories, deleting files and directories, setting the replication factors of files and directories, and so on. We typically use a curl or wget command in Linux to interact with these systems. Really, anything that you can use on your system to fire off a web URL will be able to interact with WebHDFS and HTTPFS. Both of these systems use the exact same API commands. The HTTPFS calls actually use WebHDFS in the URL of the call. So be careful when you're looking at a system. Don't assume that the user is using WebHDFS just because it says that in the call. Both of these systems can use strong, meaning Kerberos, or the weak base Hadoop authentication. Individual commands can set the user and password, or just use the user and password that, again, the command is being run as on the client. WebHDFS and HTTPFS have several differences between them. WebHDFS is by far the simplest to deploy. It's simply one single configuration change on the name node, and then the name node and data nodes need to be restarted. It does, however, require direct client access to every data node in the cluster. If you have a very secure system, you may not allow this. You may not want every one of your clients to be able to access every one of the data nodes. For that need, HTTPFS was invented. The system was formerly known as Hoop, and you may see some documents still laying around on the web referring to HTTPFS by that name. This requires the setup of an HTTPFS server. You can put this again on this machine that we've been talking about to support or help our cluster. This is typically the same machine where we would store the Hive and Pig web services, as well as the Metastore, Uzi, so on and so forth. Using HTTPFS means that only the HTTPFS server requires direct access to the data nodes. Users then submit their requests into the HTTPFS server, and HTTPFS interacts between the cluster and the users themselves no longer need direct client access. Let's zoom in on some of the REST calls that we can fire off with these commands. The URLs follow this common pattern where we're specifying the host. This is either the name node host or host of where HTTPFS server is installed. The port, which again varies depending on whether we're using the name node or HTTPFS, and then /webhdfs /v1 / and then the path to the file or directory we want to interact with, and the operation, which appears after the query string. To see some real concrete examples, let's actually walk through a few. In this first example, we're doing a curl, and we're saying we're going to put some file up into HDFS. We're specifying again a host and a port of our remote service, WebHDFS, v1, and then the path in HDFS that we want to interact with. In this case, we're going to create a file in the foo directory, and this file is going to be named bar. We also pass with the put command a -t local.txt. So we're going to take what's in local.txt on the local file system. We're going to put it up into HDFS in a file inside the /foo directory, and that file is going to be named bar. Again, the operations that we perform are typically all uppercase. Let's look at a couple more. Here we're saying that we just want to open a file. So now that we've put the file up, we can read the file back. This would spit the contents of the file back to standard out, which we could then use in a Linux redirect command to redirect it to a file. In this case, we're just listing the file status. We would get permissions and the write time and so forth. Here, we're issuing the operation of delete, where we delete that file back out of the file system. And here, we're going to go in and specify a make directory command, creating this directory called baz in the top level of HDFS. Some notes about some of these curl commands. A -i tells us to send back the HTTP header in the output. This is useful to see what commands were actually run. The -x put will override the default get method. The -l is to follow redirects in the case of when we need to access this bar file. It should be important to note that the port for WebHDFS is just the name node's web port. Again, all we did with WebHDFS was enable WebHDFS. The default port of 50070 is typically what we specify here, whereas for HTTPFS, the port is the HTTPFS port, the port of the HTTPFS server. By default, that is set to 14,000. Again, the host name is going to vary depending on where the name node or the HTTPFS server is installed. Next up, let's look at a very different system called FuseDFS. Fuse stands for File System in User Space. A Fuse system is a generic system that lets us mount a remote file store as though it were local. In this case, Fuse HDFS lets users mount HDFS as though it were a local disk, just like a C or D drive on a Windows machine. There are many Fuse implementations that exist for other virtual systems, like Amazon's S3, Cassandra, Box.net, and so forth. This is an extremely useful way to make HDFS accessible for novice users. For example, managers can run their Excel macros right on the HDFS data, or data entry folks can write data directly to HDFS without having to run any of these tricky Hadoop FS or Web HDFS calls. But it's important to educate and sandbox these people, making sure they can't do too much damage. Make sure that these folks understand that their data is on a remote system. I've heard of users going crazy thinking that they all of a sudden have a huge disk that's only theirs and filling that disk up with a bunch of garbage. User quotas in this case are a must. You should review the deck where we talk about user quotas. After reviewing this deck, you should now have a good high-level overview and understanding of what WebHDFS, HTTPFS, and FuseDFS are all about.